Okay, we're going to look at a brief review of factoring, and this whole unit is going to be a lot of it focused on what we can do with factoring any kind of polynomial. But yeah, let's just remind ourselves of some key things. So we'll just go through some common different cases of factoring that you should have seen hopefully in previous years. Okay, so the first case, 4m squared minus 25. This is a difference of squares. So remember, a difference of squares is when you have some perfect square, subtract another perfect square. To factor it, all you have to do is take the square root. So the square root of 4m squared is just 2m. And the square root of 25 is 5. And we just do plus and minus the same thing. So 2m plus 5, 2m minus 5. And that's a difference of squares. So that's our first kind of case. As we're going through these, try all of these on your own first, so don't hesitate to pause the video and just try it out. A lot of these you should hopefully be able to get on your own. But if you don't, then follow through with the video. Okay, so for this next one, it's x plus 1 squared minus 9. 9 is a perfect square, it's 3 squared. And so this is actually just a difference of squares. In this case, though, the first part is going to become just x plus 1. So that's kind of this here. And then we still have to add and subtract the second part. Then 9, the square root of that is 3. So we can add 3 like that. And then do x plus 1, the first part, subtract the 3. We can simplify this a little bit more. We can do this as x plus 4 and x minus 2. So there we've got it. We factored that difference of squares. Okay, and then we're on to trinomials. So regularly with trinomials, we're looking for things that multiply and add. In this case, we're looking at things that multiply to 36 and add to negative 12. So just run through whatever options will do that. So you might think of a various different factors of 36, and eventually you will come to, I have to think of them too. You could do 18 and 2, that won't quite work. 9 and 4 won't quite work. Oh, 6 and 6, negative 6 and negative 6. X minus 6, x minus 6, negative 6 multiply to 36. Becomes positive because they're both negative, and then they subtract to 12. So we have x minus 6 times x minus 6. You could also write that as x minus 6 squared. So that's actually a perfect square trinomial, where the square root of the 36, if you look at the middle term, well, that middle term is actually just double the square root of 36, which is 6. Okay, f to the 4 minus 2f squared minus 35. It might look a little different because these are now 4 and 2, but it's really going to work the same way. We're just going to have to adjust things just ever so slightly. But let's just first of all think of two things that multiply, in this case to negative 35, and add to negative 2. And in this case, that's going to be 7 and, well, negative 7 and 5. Okay, so we're going to have minus 7, and we're going to have a plus 5. And in this case, since it's f to the 4 and f squared, instead of having just like an x like we had before, we will now have f squared. That's kind of the term that we're dealing with here. F squared minus 7, f squared plus 5. All right, sorry about that. Let's continue. So we have that. So yeah, sometimes you just have to change what your actual, let's say, variable you're looking at. Because the first one, f squared squared, would actually equal to f to the 4. And then it's also the middle term, and then just not present in the last one. In this next one, again, you now have multiple variables, but we can treat it kind of like a regular trinomial and go from there. So let's just look at the coefficients, the 6, 11, and 3. In this case, since we have a lead coefficient of 6, we need to combine that with the 3. So we're looking at the outsides, and that's what we're looking at in terms of what multiplies together. and then we're adding to negative 11. So two numbers that do that will be negative 2 and negative 9. So in this case, what we can do with those two numbers, since we have a lead coefficient in front of the 6p squared, we want to actually break down, decompose the middle term into those two numbers that we just found. So minus 9 pq minus 2pq plus 3q squared. And you'll see essentially like the q squared and the q might make things look differently, but if I were to just in a sense get rid of them, you'd have something that looks like just a regular trinomial. So we can still apply the same techniques, and all we'll see is that we'll just have an extra q in our binomials at the end instead of just a single variable in the binomials. Okay, so for decomposition, we break down that middle term into the two parts, and then we just common factor. So in the first two, if we common factor the first two, we can take out a 3 and we can take out a p. So we can do 3p, and then we'll be left with 2p minus 3q. All right, and in the second pair, we have q in both of them, so we can take that out. And I don't like having the minus at the start, so let's factor out the minus. So we'll just do minus q, and then we're left with, well, 2p minus now 3q. The squared goes down by 1 because we factored out a q. All right, and whenever you're doing decomposition, you should get these two sets of brackets matching. And then that will basically lead to our final answer. So the first set will be the 3p minus q, the parts that we factored out essentially, and the second set, 2p minus 3q, is the parts that were left over. All right, and there is factoring using decomposition. So we can use that in cases where you have some sort of lead coefficient. All right, continuing onwards, we have 12k cubed plus 22k squared plus 8k. So whenever you're going through factoring, double check if you can do any sort of common factoring at the start. That can sometimes simplify things, especially in this case when it looks like you have this k cubed part. What would you do with that? Well, they all have k's in them. Not only that, they're all multiples of 2. So let's factor out a 2k. And you will be left with 6k squared plus 11k plus 4. And now we can just factor that trinomial there just like we normally would. So I'm going to get two numbers that multiply. I'm just going to do this to the side. Multiply to 6 times 4, which is 24. So two numbers that multiply to 24 and add to 11. And that will be 8 and 3, both of them positive. Since we have that lead coefficient, we're just going to break down the middle term into 8 and 3, those two numbers we found out. And then just as we did in the previous example, common factor whatever you can in terms of the pairs. So the first pair and the second pair. So we have 6 and an 8. We can common factor another 2 there. We have a k squared and a k, so we can do 2k. And that's going to leave us with 3k plus 4. There's nothing we can really common factor in the next set, 3k plus 4. So I'm just going to rewrite it just with brackets just to show that it's actually matching what we had in the other set of brackets. And so now we can finalize things. We can write 2k at the front here. That's just out in front. It's just not playing a role anymore in the other parts. And then we can have our first set of brackets here be 3k plus 4, and the second one can be the 2k. And since we have plus and there's nothing in front, no coefficient, it'd just be like it's a 1 in front. 1 times 3k plus 4. So we would include a 1 there in the next set of brackets. And so there we have that factored. Okay, so hopefully things are being remembered. Might take a little bit of a adjustment getting back used to this factoring, but we will be doing lots of factoring in this unit. Okay, in this next one, mn minus 5n plus qn minus 5q. There's no squared things here. There's 4 terms. Sometimes if you have 4 terms, it might be handy to try grouping, especially if you see nothing that's squared. So let's just try grouping. Let's just see what happens with the first 2 and the second 2. Is there anything we can get out of the first 2? looks like we could maybe get out an m, and you're left with n minus 5. And for the second two, looks like there's a q in both of them, and you know what? We're left with n minus 5. And so in fact, we could actually do a little bit further. We have n minus 5 in both, so we could, in a sense, common factor that out. And then we're left with n plus q. It's kind of like we skipped ahead in factoring by decomposition, like we're at one of those later steps where the parts in the brackets were our one factor and the other parts created the second set of brackets. Okay, let's take a look at this next one. So this next one, we have this a squared minus b squared, and we have this 10a and this 25. This one's a little tricky because at first it might look like, oh, you just have a difference of squares there. But then there's not much you can do with the 10a and the 25. So instead, what I'm going to do is I'm just going to reorder things. I'm going to try to work with just the a's and leave the b off to the side. So if I have a squared minus 10a plus 25, and then we have minus b squared. If I look just at the a's, what multiplies to 25 and adds to negative 10, well, that will just be negative 5, negative 5. It's actually going to be a perfect square. So this would become a minus 5 squared. So yeah, that's definitely not maybe the most obvious going into that question. But once you get that, now you have this part squared minus this part squared. It just becomes a difference of squares. So we can then write this as a minus 5 plus b, a minus 5 minus b. And there we have it. That is now factored. All right, so that's a look at kind of factoring things you would have hopefully seen within previous years using decomposition or whatever methods. You don't necessarily have to use that. There are lots of other methods, tons of methods. So use whatever method you feel most comfortable with. We're going to look at just a couple of cases that are maybe new, and that's going to be a sum and difference of two cubes. So just like we have difference of squares, we can look at, well, what happens if our numbers are perfect cubes now? And we actually have this particular thing happening. So if you have a difference of cubes, what happens is like a difference of squares, you can have the difference of your two cube roots essentially. And then in the next set of brackets, you have the square plus the two together plus the square of the other one. It takes a little bit of getting used to because right now it just looks like a formula. And unlike with squares, normally you don't have a sum of two squares. That's not factorable. But with cubes, you can actually factor a sum of two perfect cubes. And it'll basically be very similar to the difference of two cubes, but just some signs flipped. Okay, so let's go through and actually apply that to a couple of questions here. Okay, so m cubed minus 216. 216 is a perfect cube. It might take a moment just to recognize that, but it does end up working out as a perfect cube because it is in fact 6 cubed. Okay, so what we can do is, to start off with, it's always just whatever the sign is, match that up and just take the cube roots. And then to do the next part, how I like to remember it is it's the square of the first term, which is just m squared. And then it's the square of the second term, and we're looking at like the 6. I don't mean square of 216. So that's going to be the end. And if you're wondering about the signs, at the end is always a plus sign, no matter which version you're looking at, whether it's a difference or a sum. Okay, so at the end I'm going to have 6 squared, which is, I'll write it as 6 squared, but we'll simplify that to 36. And then in between, this is where we just have the 2, the m and the 6 combined together, which will just be 6m. In terms of the sign, is just the opposite sign of whatever you wrote before. So this was a minus sign, so this plus sign is the opposite. And again, the end, that is always a plus sign. Okay, And I'll just simplify that just so that it is 36 at the end there. Okay, and there we go. So that's making use of the first version here. Now let's make use of the second version. So this is also a difference of cubes, or not difference, sum of cubes, because 27 is just 3 cubed. So let's go ahead and factor this. So again, take the cube root of both of them. You'll have x, and this time match the sign with the sign inside your bracket. So x cubed plus 27 will lead to x plus 3. And then, again, just the squares of both numbers will be at the ends of the second set of brackets. So x squared, and what's 3 squared? Well, that's going to be 9. And then in the middle, it's the opposite sign, so it's going to be minus, and then just the two cube roots multiplied together. So it's going to be x, and it was a 3. That was the cube root of 27, so it's just going to be 3x. And there we have it. Okay, let's go through one more. So this one looks a little different because it's x to the 6, and you have a number in front, but it can still be written as a perfect cube. If it's not cubed, you can think of it as it's x squared to the power of 3. The 64 itself, well, the 64 is just 4 cubed. 344, or 343, I should say, is just the cube root of 7. Or 7 cubed is 344, or 343. And then, of course, well, y cubed will give you y cubed. So yeah, the key thing is identify what numbers are cubing to give you those parts. So they're all perfect cubes, and so now we can factor. So sometimes, yeah, it takes a little bit of work identifying, but it does work out in this case. So the first part will be the 4 and the x squared. Minus, because that's their sign there, the 7 and the y. All right, and then we just have to do the square. So what is 4x squared? I'll do that below. 4x squared is equal to, or 4x squared, I should say, is equal to 16x to the 4. And so that's going to go into the start, 16x to the 4. What is 7y squared? Well, that's just 7 squared, which is 49. And y squared is, well, y squared. So that's going to go at the end with a plus sign. And in the middle, we have the opposite sign of what we started with. So we started with a minus, we have a plus, and then just the 2 multiplied together. So it's just going to be 4x squared times the 7y, which will be 4x squared times the 7y will just be 28x squared y. And so that goes into the middle. So 28x squared y. So yeah, it takes getting used to, but once you get kind of more practice with it, you should get more used to that kind of pattern of square of the first part, square of the last part, and the 2 combined together to get that second set of brackets. And that's on this last part too. So, or this is part of remembering the sign. So negative starts with negative and then flips to a positive. Whereas if you have a sum of cubes, you start with a positive and then you flip to a negative. All right, that's a look at factoring. Hopefully most of it is review, and then a little bit of new factoring just to get you thinking a little bit more in depth about factoring and what we're going to be encountering this unit.